We stopped on example 4, and if you'll remember on Tuesday, all we got done was the long division. Remember, when do you know you have to do long division? When the numerator has a degree that's higher to or equal to the denominator's degree. You have to do long division. So we did our long division. Now we have to do a partial fraction decomposition on the remainder. Do you remember what's the first step? Factor the denominator, good. Okay, if we take an x out, will that denominator factor further? Oh. X plus 1 times x plus 1. In a partial fraction decomposition, you're going to have to write it like so. So that's going to be our denominator. So I'm going to have 5x squared plus 20x plus 6 over x times x plus 1 quantity squared. How many fractions, let me back this up. How many factors do you have in that denominator? You got 3, x plus 1, and x plus 1. So how many fractions are you going to have in your decomposition? 3. 1, 2, 3. All right, first one's going to have x. So what's the numerator going to be? Constant a. Good. Now, I don't remember how much we talked about this. Do you remember how to set up the other two denominators? Vaguely, okay. You got it almost. Notice that you've got a linear factor raised to a power, right? X plus 1 is linear. So I'm going to have to do x plus 1, and then I'm going to have to do x plus 1 quantity squared. If that had been an x plus 1 quantity cubed, we'd have had an x plus 1, an x plus 1 quantity squared, and an x plus 1 quantity cubed. Why? Because I don't know that's the way it works. I have never seen a proof of partial fractions. I can tell you this. I can tell you that when we finish, if we added those 3 fractions back together, I guarantee you we're going to get this. Okay? I hear what you're saying, but when you do it, it won't end up that way. I promise. Because there would be something in the numerator that, like an x, that would cancel with an x in the bottom. All right, so this factor is linear, so the numerator is going to be a constant. Abby, you're going to be totally lost. If you haven't watched a video, you're going to be totally lost. This factor is linear, so the numerator is going to have to be constant. No, you don't worry about the exponent. You just look at the factor. Because that's the way you do partial fractions. I don't have a better answer. I know. I don't have a better answer. All I'm looking for is what's being raised to that power. That's what tells me if the numerator's linear, constant, whatever. What's being... What's being raised to the second power? X plus 1. X plus 1 is linear. So the numerator is going to have to be constant. All right. Now we're ready to get rid of fractions. And we're going to do that. And we're going to do that by doing what? Yep, we're going to multiply everything by the common denominator, which is x times x plus 1 quantity squared. Now remember, we're going to multiply all 4 of these terms, here, 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 and here, by this. When we multiply here, what do we have? Whole denominator will cancel out. Now we're going to distribute here. A times what? X plus 1 quantity squared. My stomach's growling. I apologize. And I have a cold too, so I'm sniffing, and I apologize for that too. Yeah. Distribute here. Right. So it's going to be plus b times x plus 1. And then here. You get to that point, and the rest of this is algebra, all right? And you love algebra. So, I love algebra. Algebra rocks. Okay. I want you to see if you can do this piece all in your head. So we got 5x squared plus 20x plus 6 equals. Let's multiply out x plus 1 quantity squared. That's going to give us x squared plus 2x plus 1. And then let's multiply each of those terms by a. Ax squared. It would have been 2x, 2ax, and then 1 times a. And then we distribute here. Do you remember what we did at this point? Combine like terms on the right. A plus b. So I've got this gone, and I've got this gone. Two a plus b plus c. So that's gone, and that's gone. And then plus a, yeah. Yeah, but this old boy isn't too bad. Isn't too bad. What does a plus b have to equal? 5. All right. So a plus b has to equal 5. What does 2a plus b plus c have to equal? 20. And a equals 6. Hallelujah. I know what a is. If a is 6, b is negative 1. Question. Because the coefficient of the x squared over here must equal the coefficient of the x squared over here. C is 5. 2 times 6 plus negative 1 plus c equal 20. 9. Whoa, okay. Hold up. Okay, hold up. All right, I'm holding up. What's the matter? We're kidding. Okay, so we're good? Now let's go all the way back up here. Now, The way you're going to write your answer, this equals. That's how you're going to write it. So you're going to read it to me because I don't want to have to keep scrolling back and forth. Read me that big old nasty fraction. X to the fourth. Keep going. Thank you. Now remember, that equals x plus. Remember that x came from the long division right here. That plus these fractions. A is 6. B is -1. Was that x plus 1 or x minus 1? I forgot. Plus 1, thank you. Plus 9 over there is your partial fraction decomposition. Question. Why is this x right here? Because when I did long division, it was x plus this fraction. This partial fraction decomposition just broke down this fraction. So the answer is x plus that fraction. It would be the same thing, and this is a real simplified example, but if I gave you 6/4 and you wrote it as 1 2/4, you wouldn't just say your answer was a half. You have to bring the 1 along. It's just the same idea. I have to bring that x along. Okay? You're not going to have one really more messy than that one. What about the one below it? I got your back. Trust me. Question? It sure looks easier. No, I got your back. You got to trust me. Do we need to do long division on example 5? No! Yay! Yeah, thank goodness. I'm hearing you guys mutter. Okay, I don't have to. Now, we just start, which means we do what? Factor the denominator. So I got 3x squared plus 4x plus 4 over, I don't think I know how to factor that. X times x squared plus 4. Will x squared plus 4 factor further? Would it? It's not. Is that a difference of 2 squares? So it won't factor as x minus 2x plus 2, will it? So we say that's that's factored completely, is what we say. So now we're ready to move on. There are only going to be 2 fractions. The denominator here is linear, so my numerator will be constant. The denominator here is quadratic, so the numerator has to be linear, 1 degree smaller. So what does linear look like? Linear will look like this. That's what linear will look like. Question, Nick.
So let's say there's another factor.
Yep.
Would it would go to D?
Yep. We go to D next if we had another factor, right? If the denominator was cubic, what would the numerator look like? Bx squared plus CX plus D. There you go. There you go. You're not going to have any of those. All right, let's go. What do we do? Multiply by the common denominator. Distribute, distribute, and distribute. Questions? Can you finish it? You finish it and I'll finish it. We'll see if we get the same thing. Go ahead, I'm listening. Did I lose something?
It's 4A, not 4A, not 4X.
4A, wait. Oh, snap. You're right. You're right. You're right. Right. 4A. So now I've got plus CX plus 4A. Thank you. Thank you. Tell me if I screwed it up again. What do you know? What do you know? I got it right. What do you know? Questions?
Did the 4 that you see what
CX has to equal 4X, so C has to equal 4. Where? Where are you confused?
Why? Is there like a specific orders that we have to put it in to... Have you put it in like that standard? Basically.
When?
You'd be able to know. Yes.
Yes. The answer to that is yes. Yes, I would. Problem was, whatever it says under there, 3x squared plus 4x plus 4. Over x cubed plus 4x squared, I hope that's right. Equals, yeah, do it to the original. Equals, what was it, a over x? And a was 1. And this was x squared plus 4. And that was bx plus c, yeah, so 2x plus 4. I don't know what that was. Well, there are 2 more. There's just 1 more that's not on your paper. Yeah, I know. All right. Now this one, listen. This one's also pretty easy. It's about the same difficulty level as the one you just finished. Yeah. That's not hard either.
Yeah.
Yeah, I know you don't have that one. Yeah. All right, number 6. Do we need to do long division?
No.
Yes. It's a degree.
No.
Because it's to the good, like a 4. Because if you multiply it out, multiply it out, it'd be
It would be a degree 4, right. If you multiplied that bottom out, that would be a degree 4. So do we have to do long division? No. What? Is the bottom already factored? Yes. So we don't have to do long division. The bottom's already factored. How many fractions? 2. Good. That's it. If you have something raised to a power, you've got to do this process. You'd have to go to a college professor to get, like a PhD would obviously know more than I would. So I don't know why this works. I just know it does. And I know it, yeah. I just know that if I add these two fractions back together when I'm finished, I get that. And that's enough convincing for me. Okay. Degree? Because what's the degree of this? Quadratic, so the numerator is linear, ax plus b. Good. Now, the factor here still is x squared plus 2. Quadratic. Numerator must again be linear.
The fact that it's squared doesn't matter.
No. You are going to see a problem on the assignment where this is in the denominator. Okay? No, I want to show you something, because this will mess you up if you don't pay attention. This is just like this. Aren't they the same thing? You have some factor raised to the second power. What's the factor here that's being raised to the second power? So you're going to have...
I get why it's different, because if it was x and x, then you could just add them up.
And be 2x.
Okay, that's enough.
There you go. Well done. Okay. Here. Let's finish it before lunch. Come on. Come on.
Who is in Mr. Walker's third or eighth
Come on. What do you do?
period class
We'll find out.
and his 8-hour aids. Also, this is Woodley's fifth period class, needs to go to room 700 at 12:30. Thank you.
Questions? Now, what are you going to do right here? Yeah, distribute FOIL. Well, there you go. I can just do it pretty fast. I do not have my notes memorized. It's on the inside of my glasses. They are not like the icosahedron over there where they're one way. Yeah. That's right. That's right. So I got ax cubed plus bx squared plus, what's x? Hang on. What's x? 2a plus c plus d. We'll finish it after lunch. Now, I had a mistake. When you walked out of here, I had a mistake that Danae caught. I had forgotten to put the 2b in here. So make sure that your constant on the right is 2b plus d. All right, let's finish this up. Okay, what's a? A has to equal 8. What's b have to equal? 0. Because there's not an x squared on the left. What does 2a plus c have to equal? 13, but we already know that a is 8. So what's c? C is negative 3. And what is 2b plus d? 0, because there's not a constant on the right. But we already know that b is 0. So what does d have to equal? Mm-hmm. But because b is the coefficient of x squared. Okay. Questions? All right, so let's write this up. 8x cubed plus 13x over, I already forgot what the denominator was, x squared plus 2. Thank you. And we had ax plus b. So what's ax plus b? 8x over x squared plus 2. Cx plus d. There's your answer. Okay? Now, we're going to do one more real quick. Please write this down as your example 7. So you got x cubed minus 2. Go ahead and write this down as your example 7, okay? About halfway down. X cubed minus 2 over x squared plus x. Think about it for a minute in terms of what is your first step. Factor the denominator. That is a step. Is that your first one? Degree of the numerator is bigger than the degree of the denominator. So what do we have to start with? Long division. Well, it will give you, you're going to end up with something where you would have an improper fraction anyway. Do you notice that I put some placeholders in there? Do you understand why I put the placeholders in there? Why? Because what? Why does it, so what, it does make it easier, for sure. Yeah, it's like synthetic division. You need placeholders. This just helps me to keep everything lined up. All right, let's go. X cubed divided by x squared. X. What do I do with it? Multiply, good. X times x squared plus x. Yep, change the signs. Question? What's the matter, Brooklyn?
Why is it X?
Because I did first term on the inside divided by first term on the outside.
Right.
Mm-hmm. Now I'm going to change the signs. Negative 1x squared. Bring down. Can I divide again? What's negative x squared divided by x squared? -1. -1 times x squared plus x. Once I multiply, what do I have to do with it? Change the signs. 0, x, can I divide again? No, because the degree of x is smaller than the degree of x squared. So this sucker looks like x minus 1 plus what? Yep, x minus 2 over x squared plus x. Yep. This is actually pretty easy to finish.
So that's that whole thing after that. Like that's the do that. Right. Well,
Almost. This is essentially, I have rewritten an improper fraction as a mixed number. Now the question is, will the fraction part still simplify? Question. Because when I did the division, which I just erased, x minus 1 was up here, right? Down here ended up being x minus 2. And out here was x squared plus x. Uh-huh. All right. Let's take that fraction and see if we can decompose it. X minus 2 over x squared plus x. Will x squared plus x simplify? Or factor, sorry. What are your numerators? Good, because both of your denominators are linear. Good. Both of your denominators are linear. Finish it. You finish it and I'll finish it and you tell me if I make a mistake again. It's just sitting right here. It was not part of a fraction anymore. So when I finish this decomposition, it's going to be plus whatever my fraction is. Huh? Let's do this and then I'll show you. Let's just finish this. Please tell me if I screwed anything up. Is this all right? So what's a plus b have to equal? 1. And what's a have to equal? So if a is -2, what's b?
3.
You getting a little more comfortable with these decompositions? All right, everybody but Abby. Abby's still kind of going, ah! Okay. You're still confused. Well, all right. Good.
I have more time trying to keep up.
Yeah, I understand. When you go back through the video, just pause it and write down what you need to write down, okay? X cubed minus 2 over x squared plus x.
Would you like the original one now?
equals x, was it minus 1? Plus negative 2 over x. That's it. This is your decomposition. Okay, good. Remember, you could write this piece right here as minus 2 over x. Whatever you want to do. Ladies and gentlemen, this is partial fraction decomposition. Now, you should be able just fine to do the rest of that assignment. But what we're going to do is a very short lesson, okay? And this really didn't even come from the book. This came from my head because it's something you need to know in calculus. I wrote these notes myself out of my head. All right. I want you to notice what the title is, difference quotient. Now, what in the world is a difference quotient? One of the basic definitions in calculus uses this thing called a difference quotient. So you're going to work a lot with it when you take calculus. If you're a junior, when you take AP, because you will, because I want you to and you want to, you will work with it a lot. It's easy. This is easy. You better take AP calculus. So, what is it? Now, let me explain something to you. What we're going to do right now is just this little bitty piece that we're not going to use ever again in pre-cal. But when you get to calculus, I want you to have seen it so that when we start using it, you already have some familiarity with it. Look at your notes. Do you see the front and 2 questions on the back, and at the bottom is the homework assignment? 4 questions, all right? So this is short. Now, there is not enough room on this paper to do those 4 problems, though. Dang. You almost got lucky, but no. What I'm going to show you is stuff you already know, just put together in a different way. I promise you already know everything I'm going to show you. I'm just going to show you how to put it together differently. We're going to start with a picture. Now I've got a graph, and I have called this graph F. Now what we're going to do, I'm going to... Well, ouch. Felt good. All right. We're gonna pick a point X. Now, put it about where I have because you're going to want some space. Now, right here is the point on the curve that has an X value of X. What's the Y value? AKA f of X. So the coordinates at this point right here are X, f of X. Now, we are going to move to the right some distance. And that distance is going to be h. So I want you to do this. H. I don't care how far you make it. H. What is the x value right there? That's it, x plus h. Now, if we go up to the curve, what are the coordinates of that point right there? You got the first half right. It's x plus h is the x value. Right. And the y value is f of that.
Why is on the first one x and then fx is it just 'cause it's on that line? That's the y value?
Remember, another name for f of x is y, right? So the y value here is just, let me show you what I'm talking about. If f of x equals x squared, then f of 2 would be 2 squared, and f of 3 would be 3 squared, and f of x would be x squared, right? So this is just the y value, just the y value. And for this point, if I put in x plus h, then I get f of x plus h. Now what I want you to do is, as best you can, I want you to draw a straight line. That's redundant. I want you to draw a line. I started to say straight line, but all lines are straight. I want you to draw a line between those 2 points and extend it. Don't make it just a segment. Just go ahead and get it through there. We're going to find the slope of that line.
Oh, no.
You know how to find slope.
Parabola.
How do you find the slope of a line? No, that's not how you find the slope of a line. Rise over run. So how do you do it? How do you actually do it? Walk. Well, I'm just going to tell you, go ahead and move over and stuff. Okay, so fine. Don't do this. Don't do this. Please, if I ask you to find slope of a line and you don't know the numbers, snap. What's this? What's this? What's that distance? H. What's this distance? It's part of it. What's the distance right here between my fingers? Then let's just do it normal. Let's do it with the formula, which is y2 minus y1 over x2 minus x1. Don't you remember that? Remember, rise over run? How do you find the rise? You subtract the y values. How do you find the run? You subtract the x values. Okay.
So I can erase that h line?
You can. y2 minus y1. Start with this point here. What's the y value? F of x plus h minus the other y value over
X plus h.
y2 minus y1 over x2 minus x1.
Oh, minus x.
So x plus h minus x. But that denominator will clean up just a little bit. Because x minus x is 0. Now, don't you put this on your paper. You told me that was h, right? This, Luke started it. The distance between, well, the vertical distance is the top y value minus the bottom y value, right? But the top y value is f of x plus h. Well, what's the y value of the point right here? F of x. So it's f of x plus h minus f of x. Now, we found the slope. Well, what in the world did we find the slope of? A line. But that line is special. That line is special, and I lost it. I got to get it back. It is. When you have a line that cuts through a curve more than once, And I'm going to be careful about that. So if I ever say something a little different someday and you call me on it, I'm going to expect that. That line is called a secant line. What you just found is the slope of the secant, S-E-C-A-N-T, secant line to the curve. That's what you just found. F of x plus h minus f of x over h. Learn it. Don't memorize it, learn it. You found the slope of the secant line to that curve. Now, let me give you just a little taste of calculus. Don't stop it. Little taste of calculus. Don't write this down. Just want you to absorb it, okay? You're going to take calculus next year. Now, here's my question. What if I make h smaller? What if I only make h be that big? Then my other point is right here, which means my other point on the curve would be here, right? Which means my secant line is going to be in a different place, right? My secant line would be there. Does that make sense? What if I made h even smaller? What if I made h this small? Then my other point sits right here. And my secant line would be right here. What if I let h get so small that you could not tell the difference between it and 0? What if I let h get so small that I could not tell the difference between it and 0? No, I don't round. Where would my x plus h point appear to be? Where? On this same point right here. If h is so small, it's just almost 0, then that x plus h is just it's gonna look like it's just right there. So my point would be, both points would be right there, wouldn't they? So where would my secant line be? Aha. A tangent line. What's a tangent line from geometry? What's a tangent line? Touches one time. As h gets closer and closer to 0, that secant line becomes the tangent line. And ladies and gentlemen, that is the foundation of calculus. Yep. I got your back. I got your back. All right. I told you didn't need to write that down. I was just giving you a little teaser to get you to take calculus. Sir, I didn't mean to scare you away from it. What is the point of all this? The point of all this is, this has nothing to do with your pre-calculus course, okay? This has everything to do with, I thought it was a good time to teach you a small concept that makes all the difference in the world in calculus. I want, when you walk into calculus, that when we start working with this, you already know how. So we don't have to do that background work. Go ahead.
What I meant is, like, what's the point of the h getting so close to x that it becomes...
Take calculus. Take calculus. No, it's stuff that I cannot explain to you now, because you take calculus.
Well, that's one of those things I have, that's for water.
Now, so you say, okay, fine, what the crap, this difference quotient thing. All you are going to learn how to do today is to apply the difference quotient to a function. You're like, what does it mean? In this course, it doesn't mean anything. You're just learning the practice of how to do it so that when you take calculus, we can walk right in and get it done, and you don't have to understand the foundation first. Okay?
Is this on the quiz then?
Yes. This will be on your quiz. Yes. You will be quiz tested on this thing. Of course you will. Now, I don't write this down. I just need your brain. F of x equals x squared. What's f of 3? 3 squared, which is 9. What's f of negative 1? Negative 1 squared, which is 1. What's f of a? A squared. Excuse me, I had to hiccup. What's f of c? C squared. What's f of a plus b?
A squared plus B squared.
What? It's a plus b, quantity squared. Aren't you taking this and putting it where x is? So it's a plus b, quantity squared. What is f of p plus q? It's p plus q, quantity squared. What is f of x plus h? Aha! We put x plus h everywhere we saw x. Please don't forget that. Now let's do the problems. Yeah, I missed this part. All right. The definition, the slope of the secant line. Yeah. Are you going to draw Galileo? You know what Galileo looks like? Nope. Okay. Well, all right. I'm sure you can. Now, we're going to apply the difference quotient to this function, 2x minus 3. Now, so the first piece we do is f of x plus h. If f of x is 2x minus 3, what is f of x plus h? Yes, because everywhere you saw an x, what did you put in its place? X plus h. We see an x right here. We're going to put an x plus h in its place. So that's going to be 2 times, don't write this down, don't write this down, just a minute, just a minute, just a minute. Do you believe that? Is that true?
Yes. I feel like it's wrong.
It's not wrong.
Okay.
Then you believe it, okay. Now, you got this, you okay with this? So now, f of x plus h, now you can start writing, is 2 times x plus h minus 3. Now that's the f of x plus h part. Now I do this part, minus f of x. What's f of x? 2x minus 3. Why did I put that in parentheses?
Because the negative, it's one term.
There you go. I got to subtract that whole thing. All over h. Clean it up and you're done.
Really?
Yeah. Yeah.
Is this a joke?
No, honey, it's not a joke. It's not a joke. Once you get to this point right here, if you do not have some stuff that adds up to give you 0, then you've made a mistake. Nick? What's the matter?
Okay, I looked down to write down the red thing, and I looked up, and how did you get that?
I distributed here
Oh.
and distributed here. His eyes were... Zero? Zero. So I'm left with 2h over h, which is 2. The answer's 2. That's it. What's the matter?
Yeah, there's gonna be something tricky that happens, then everyone's gonna be like, oh, here it is, you know.
So you have questions here? You just have no faith. Questions here?
Somewhere real quick.
You have...
That's quick.
All right. Next one. F of x equals x squared. We're going to apply the difference quotient to that function. Now, what is f of x plus h? It's x plus h, quantity squared. That's f of x plus h minus f of x. What's f of x? All over h. Clean it up and you're done. Please tell me you can multiply out x plus h quantity squared in your head. And if you can't, think x plus h times x plus h and FOIL. X plus h times x plus h is x squared plus 2xh plus h squared. Do you have anything that adds up to give you 0? Now let's look at what we've got left. This is 2xh plus h squared over h. What? Yeah, you don't factors out and then cancels out. You factor out that h, you factor out that h as a GCF. It is so fun to watch your faces. Like Sydney was going, and then she went, that's awesome. Okay. Question.
So you said that you had to factor in h,
Yep, I did.
but if you just take out, if you simplify the h before you take it out, and
You mean if you factor an h out of each of these?
yeah, get rid of the cost.
Yeah. But what people tend to do, Nick, don't do this because this is wrong. People will want to do this. Yeah, you can't do that because it's got to be you have to be able to factor an h out of every term. And if you want to just think it in your head, that's fine, as long as you're getting it out of every term.
And one of the h's and the other one, is that okay?
Yeah. Now, another thing you'll be able to do in calculus is you'll be able to do that in your head.
Yeah, I don't know about that.
No, you will. Mason, tell them. That you learn how to do it in your head.
Yeah, I mean, not everybody can do it, just like the best.
Do you want to throw that at him? No, I'm kidding. Don't throw that.
Really?
Yeah, you tell Coach Rippey this afternoon that is never going to reach. Yeah. Number 3. Hey, we need to do these last 2. Let's go. Number 3. Now remember, when you do x plus a, f of x plus h, everywhere you saw an x, what are you going to put in its place? X plus h. How many x's do you see? You got to put x plus h in 2 places. Because there are 2 x's.
Okay, why are we putting x plus h in first?
Because I'm trying to... Because the slope of the secant line is f of x plus h minus f of x over h. When I'm doing these, I'm finding the slope of the secant line. That's what I'm doing. So f of x plus h. Do you see that that's f of x plus h? It will be over h. I'm just not finished. Are you okay that that's f of x plus h? Minus f of x. All over h. Got this. X plus h quantity squared.
Excuse me, students, please pardon this interruption. Also, teachers, pardon the interruption. Can I have the following students to the counseling office? Megan Jackson, Taylor Keir, Grace Arrington, Sydney Pfeiffer, Jessica Robinson. Please come to the counseling office at this time. Thank you.
If we don't have some stuff that adds up to give you 0, you've made a mistake. 0, 0, 0.
Oh, so you have to do it like, on the end you have to multiply the negative sign to the.
Because I am subtracting that whole thing, so yes, I have to distribute a -1. All right, so what do we have left? Well, we have 2xh plus h squared minus 4h all over h. Can you factor an h out of the whole numerator in your head? So what would your answer be? Just that, right? Because that h will factor out, cancel. Question? Oh, sure. Yeah, that's fine. All right, we got one more. Remember, you are finding the slope of the secant line. Now, another teaser. Remember we said as h gets closer and closer to 0, the secant line becomes the tangent line. So as h gets closer and closer to 0, the slope of the secant line becomes the slope of the tangent line. What if h is 0? What does this equal? 2x minus 4 is the slope of the tangent line. And that's what you will be able to do in your head. 3 seconds max in calculus. Slope of the tangent line. Yeah. Calculus isn't hard. If you, yeah, well, yeah. Last question. Let's apply the difference quotient. F of x plus h minus f of x over h. What's f of x plus h? What's f of x plus h? 1 over. That's f of x plus h minus f of x all over h. Mrs. Seegert would love this problem.
Of course.
No, why would she love this problem? Because she taught you how to do a problem just like this. She taught you. I hope she taught you. Okay. This is called a complex fraction because you got a fraction inside a fraction. Now, we're going to take what I circled in yellow, which is the whole numerator, and we're going to find a common denominator. What's the common denominator going to be for the part I circled? X squared times x plus h quantity squared. What part is this fraction missing? What part is this fraction missing?
that?
Why do I have to multiply top and bottom by the same thing?
Because it's multiplying it.
Because I'm just multiplying it by 1, and when I multiply anything by 1, does the value change?
No.
No. Good, just the way it looks. All right. So now, I've got x squared minus x plus h squared. Now take a look at that. Since I have a common denominator, x squared times x plus h quantity squared, I can combine the numerators. X squared times 1 minus 1 times this over the denominator. Now I'm going to ask you a question. Don't write this down. 1/3 divided by h. When I divide by h, it's the same as multiplying by, which is 1 over h. So 1/3 divided by h is the same as 1/3 times the reciprocal of h is 1 over h, which would be you see this? So what can I do with h right there?
Multiply all that by 1 over h.
So if I multiplied all of this by 1 over h, would the numerator change? No. The denominator would just have a times h in it. Please believe me when I tell you the hard part's done. Now we're just going to clean it up. X squared minus do you need to multiply out the bottom? Never. 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 What do you see? Do I have an h common in the numerator? You bet. So that's h times negative 2x minus h over this bad boy down here. And that h cancels out. So my answer is negative 2x minus h over x squared times x plus h quantity squared. Just
Well, that's interesting.
All right. Your assignment is to finish your partial fractions and do the 4 problems at the bottom of this.